Word captions. Okay. Oh, so like they totally said not to have drinks. It's like you're all adults. Like, please don't spill anything and please hide them and don't let them come down and see these drinks. Because if they say something to me again, then I might actually have to enforce it. I'd prefer not to because like, you guys are.
Sound like water with beers.
I don't know if it was that room. They said something about the lab last time, so it might just be that room, but they just did not want drinks down here. And then I like had Jimmy John's and she kind of just looked at me and I was like, so come on. Finley, got you. Justin, you're here. Annabelle. Annabelle, are you here? Yep, right there. Okay. Trying to get everybody's name. Jasmine, got you. Victoria, got you. Lizette, right? Allie, I see. Zia, you are not. You're Jasmine? No, okay. Rosalind, got you. Andrea, you're here. Olivia, Jacob, not. You gotta think you're. Don't say it for me. So I, Kellyanne, okay. That's what I was thinking. I just didn't want to like say it wrong. All right, Kellyanne, cool. Lincoln, are you here? Right there in the back. Perfect. Emma, perfect. Jordan, you're here. Eli, I see. Okay, cool. All right, so probability. I think the most fun chapter, but yeah. Let's, show. Yeah, probability. So probability is the frequency of times the outcome occurs divided by the total number of possible outcomes. Symbolizes P probability. This is the formula you'll be seeing shortly. Is used to predict any random event. Any event where the outcome observed in the event can vary is your random event. A fixed event is where the outcome is always the same. It wouldn't be necessary in a fixed event because it's fixed. We have that so far. So, okay. So probability. So we're gonna cover these things: probability, calculating probability, relative frequency, relationship between multiple outcomes, conditional probabilities, Bayes' theorem, probability distributions, mean of probability distribution, expected value, variance, standard deviation of probability distribution, expected value binomial distribution, and mean variance and standard deviation of binomial distribution. So this is how you calculate probability. So you need to know the number of total possible outcomes, the sample space, how often the outcome of interest occurs. So the equation of probability, Fx equals the frequency of times outcome occurs, X over the sample space. Compute probability, follow 2 steps, find the sample space, and find F of X. Then you get basically a percentage. Anyone ever play cards ever? Like any card game? And there's probability of what you get dealt, right? Because it's kind of like, look, there's a formula for this. So if you take the probability of picking a specific card, you can plug that in. Let's say you're playing like blackjack, you want face cards, right? That's usually helpful, or an ace or a face card. So let's think about like a particular face card or like an ace. There's 4 of them, right? Because there's 4 suits. So let's say you want a king. Your probability would be 4 because there's 4 of them, and there's 52. That'd be your chance of getting that card dealt to you if you're, say, trying to win, say, in Vegas. Anyone have a number for me? What's 4 into 52? Is that making sense? I'm literally putting this into that. What's the percentage of getting the card? Should be pretty low, probably about like 6-7%. So I have a number for me. 4 into 52. Or should I do the math? What's the chance of getting that face card that you want? Or an ace? There's 4 of them in the deck. Do you have the number? What was that? Is that a guess? Should we do it together? I think it's a little higher than 5%. It's not much higher though. Sounds about right. So you have 7.6% chance of getting the card you want. Now out of 100, it would either be 48 divided by 52 or whatever left over, right? that would be your chance of not getting the card that you want, right? So we should have what, approximately 92.4? 92.4% chance of not getting the card that you want. And we're just talking like just the card that you want to come up. But math is really cool, guys. So let's take this a step further. We're gonna take cards. Plastics on it, please shuffle them. Want to do the honor of opening them? I'm gonna see if I can get this to happen just for fun. That's where my odds are for probability, because math is cool. Let's see if I get it right. Not. You want to open these? You want to shuffle them?
Sure.
So we should open them and we should go to the jokers and like directions. It's got to be 52 cards. Okay. I'm going to see if I can get a card to come up. Not the suit, because this is math. Okay. The right number. So Justin, please make sure that like we're actually doing math here. That's a legit brand deck of cards.
Charge, guys, don't worry.
Remove all the jokers and the directions so we have a real 52 deck card so our math works.
When you want me to shuffle?
As long as we have just the suit cards, no jokers, shuffle as much as you like. And if anyone else wants to shuffle or examine the deck of cards, that's fine. Okay. And you can refer me to the cellophane off. There's no trick. We're just doing math.
Yeah, the cellophane is in fact off.
Yeah.
Am I supposed to, or someone else supposed to pick the card?
No. I'm going to do something with them that involves math, and I'm going to guess and see if I'm right.
Yeah.
Or I'm going to use math to get it right. Or I'm going to have a nice epic fail of this. The odds are stacked against me.
Yeah.
But math is cool. If I do it right, it's mathematical. And I'll get the card that I say before I actually look at it. If I do it wrong, then bad odds. So shuffle as many times as you like. Encourage other people to shuffle whatever you'd like, and then either I'll get the cards from you or bring them up here so that I'm not doing any sleight of hand stuff, because I'm absolutely not. It's just math. Okay.
What?
I got it somewhere where you guys can see it. It doesn't matter if it's back there or up here. Just the idea is that you guys can actually see. When you're thoroughly shuffled, shuffle as much as you'd like. Just bring the full deck up here and we'll see if it can happen.
You want them back?
I do want them back because I'm going to see if I can do this. No jokers. They're all with you, right?
Follow the rules.
Okay. All right. Okay. You guys can stand up and come up, or you can look from your desk, whatever you like. Okay. If it's shuffled, I'm not shuffled. All right. Okay. I have 7 piles. You guys can remove any 4 you'd like. I recommend getting rid of thin piles, so I didn't just memorize, but I just looked at. So I'm not cheating. Anyone, take whatever piles away you'd like. You gotta leave 3. There's more cards than thicker piles, so just leave
You want 3 piles?
3 piles, like I said.
3 need to be left.
Assuming I don't have a photographic memory,
Take it.
that's, yep.
Does anybody else wanna do
Yeah,
this or
anybody else
no?
wanna come?
We'll see if this probability works or not.
Where, which one?
Just grabbing
Good job.
Any pile, so then one more,
Pick it up here.
Right.
Get up.
I'll just take this.
and then one more.
No, wait, I wanna see his, give me his.
Okay, so I need those,
Oh.
Oh.
not doing anything, okay, so these 3 piles.
Wait, you still got them too.
Oh, perfect, okay. You guys can move the piles around, but don't mess up the order the cards are in. I won't even look. Just don't be shuffling them together, okay?
Just watch.
But you can move those around. Just to make sure we're doing math here, okay?
I'm just playing a card game. I don't know what you're doing.
I feel like we're getting magic.
No, it's absolutely mathematical.
You pull a rabbit out of a hat?
I'm not pulling around on a hat, just having fun with
Oh,
probability.
good job. Come on.
I feel like we need a little bunny.
You're the bunny. He likes the bunny.
There's a bunny.
Alright, you're good.
For what?
All right. Which top card should I try to predict? This one, that one, or that one?
The middle one.
The middle one?
Sure. That's not the middle one. Listen.
The
Yeah,
middle
that one.
Okay.
I'm watching this magic trick.
That is a 10.
Wait, is it?
Just, I got that one.
It
Math
is.
is cool, guys.
It was
That's
magic.
probability.
It was magic.
It was math, guys. Just math, just math.
You didn't even put those up, you had it still face down.
Yeah, it's math.
Well, how did
Just-
you know?
I was probably counting something.
You cheated, but I'm getting, you know.
Math, guys, just math. It's not magic, it's just math.
You want your jokes?
Sure, yeah, if you want. So. Able to hit that. Some math.
New instructions.
Alright. So when verify. When solving the probability equation between 0 and 1. 1 is like 100, 0 is like a possibility. Closer to 1 more probable, closer to 0 more improbable. Probability is never negative because it's the probability of the thing happening. You wouldn't have negative probability. Yeah, okay. So probability to relative frequency, probability of the occurrence, relative frequency, distribute the frequencies, either sample space. Look at the sum of the frequencies. That's always your denominator. And then distribute the relative frequencies that reflects the probability for each outcome in this in the distribution, which we'll segue to in just a moment. We have four different types of relationships: mutually exclusive, independent, complementary, and conditional. And then we're going to walk through how those work in terms of probability in a moment. As well as what they are. So mutually exclusive, two outcomes cannot occur together. The N symbol is for and. For example, one flip of a coin, one event, not possible to flip ahead. Outcome one and tail outcome two. You can't have heads and tails at the same time. That's why it's mutually exclusive. It cannot happen together. So we use the additive rule. The probability of any outcomes occurring equals to the sum of the individual probabilities. Probability of A or B equals the probability of A plus probability of B, where this is a symbol for or. And in this case, it'd be 50% because there's two different outcomes. Equaling 100% or one. Does everybody have this so far? Are you still writing? Okay. So we have an independent outcome. And the probability of one outcome does not affect the probability of the second outcome. So I flip a coin twice, the event, outcome one, heads or tails, does not affect outcome two. In this case, we use the multiplicative rule. Probability of both outcomes is a product of the individual probabilities. Probability of A and B is equal to the probability of A times probability of B. Because they're independent from each other. Is it right back there? So we have this so far. Okay. So we have complementary outcomes. The sum of all possibilities equal to 1 or 100% is out if the outcome is exhausted of all possible outcomes. For example, flip a coin one time is your event, probability of flipping head outcome 1 or tail outcome 2, 1.00. Two outcomes, head or tail, exhaustive of all possible outcomes for this event. Subtracting 1 from the probability of the outcome will equal the probability of the second outcome. Heads or tails. Thank you. Yes, everybody, not talk to me. Additional outcomes. Probability of the outcome dependent on the occurrence of or the outcome. Probability of the occurrence changed by the occurrence or of an outcome. It's this formula. For example, you want to determine the probability of drawing 2 heart cards from the deck. The deck is 52 cards, which each has 13 hearts. On the second draw, the deck is 51 cards, only have 12 are hearts, so the probability changes. Because you drew one of the heart cards. So your sample space is lower and your frequency of the thing is lower because one of the cards is now taken away. So, another example, probability of one event, A, given another event occurred, symbolized by I. Probability of selecting uninsured mother, U, who gave birth in a public hospital, P. Probably public hospital, the uninsured mother, P and U, equals 80 divided by 200 is equal to 0.40 or 40%. Selecting uninsured mother given she gave birth, like hospital, probability of U divided by P, 80 divided by 130, 0.62. Then you can check it to see if it makes sense. And we get our percentage of 0.62. 40 divided by 0.65. Our table supports that math. If it doesn't make sense, talk to me, you can walk through it. The Bayes theorem formula relates conditional marginal. Unconditional probabilities of two conditional outcomes occur at random. It's a modified formula for conditional probabilities, which can be used to make inferences concerning parameters in a given population. Probability distributions, a random variable, which would be a variable obtained or measured in a random experiment. Not the actual outcome of the random experiment, but describes possible outcomes in the random experiment. We can describe outcomes for any behavior that varies from person to person or from situation to situation in terms of the practical application of a random variable. Let's think behaviorally. So we did probability distributions, the distribution of probabilities for each outcome of a random variable, probability for obtaining each possible outcome of a random variable. Each probability distribution ranges from 0 to 1, can never be negative. The sum of probabilities, which is what we have on our equation below, in the distribution for a random variable x is equal to 1. So the sum of the probability of x is equal to 1, 100%. We have this so far. Okay. So, an example, research records the number of participants rating certain situations as stressful on a 5-point scale. And then we're constructing the probability distribution for the ratings, and it would look like this. Well, we're taking these. You can take this and the 80, you get that. Take this and 80, you get that. Like that's where they're coming from. Just so everyone's on the same page, etc. So the sum of the thing happening, the frequency of the event, 80 total, the sum of the probability of the thing happening, 1.00 in decimal form, or that would be 100%. If you multiply it by 100, that's how you get that. Take it from decimal, or divide by 100, take it from percent back to decimal. So we have that so far. Okay. Mean, or the average of the probability distribution expected value. Expected value, mean, or average expected outcome for a given random variable. To compute the mean value, you know that with the Greek letter mu. Multiply each possible outcome by the probability of its occurrence, or P. Sum each product, so the mean is equal to the sum of X times probability. Expected outcome, sum of the products for each random outcome multiplied by the probability of the occurrence. The mean of the probability distribution, expected value continued. To determine the expected value for random variable, compute the mean for the probability distribution. The mean of the probability distribution value will occur on average. Makes more sense. So do we have that so far? Okay. Variance and standard deviation of probability distribution. It's necessary to determine the distribution of outcomes for a random variable. The expected value gives only the average outcome of a random variable. You can compute the variance of the probability distribution and the standard deviation of the probability distribution. Okay, the variance, standard deviation, and probability distribution continued. Variance of probability distribution is noted like that. Just theta squared. Measure variability. average square distance, outcomes deviate from the expected value, the mean, and it's that formula right there. Is equal to the sum of x minus the mean squared times probability. Sum of x minus the mean squared times probability. The standard deviation of probability distribution looks like that, because we're going to square root it. It's a measure of variability. Average distance outcomes deviate from the expected value mean. We do this by square rooting the variance. So the square root of the variance is equivalent to square root of the sum of x minus the mean squared times probability. It's the same formula. Computational formulas. Probability variance, standard deviation. Variance is equal to the sum of the values squared times probability minus the mean squared. Standard deviation is equal to the square root. Just square rooting the variant, just square rooting that, which is square rooting the variance is standard deviation, which is also equivalent to the square root of the sum of x squared times probability minus the mean squared. Expected value binomial distribution. This is the distribution of probabilities for each outcome of a bivariate random variable. Two possible outcomes can occur by natural occurrence, such as flipping heads or tails with a coin. Outcomes for we calculate the outcomes of the random variable. This can occur by manipulation. Outcomes for self-esteem among children, for example, high or low, potential for more outcomes. And then you can have manipulated data for two possible outcomes, like high or low self-esteem. I believe the math is on the next page. What do you have? That? Okay. So here's our equation. Number of times random variable observed is n in the equation. The probability of the outcome of interest in the individual observation is p. And then, of course, our Greek mu is the mean. Mean is equal to n random variable observed times probability of the outcome of interest in the individual observation, p. The variance standard deviation of binomial distribution. Variance of binomial distribution is that formula right there. Standard deviation of binomial distribution, square root of variance is that formula. And then for both formulas, we have the nice breakdown. N number of times the random variable observed, P probability or outcome of interest, Q probability of complementary binomial outcome, P and Q are complementary events, so Q is equal to 1 minus P. This and some of the other or involved probability will be addressed with the pretest and the post-test, by the way. And the second worksheet, what we'll probably do is, this is our last slide. Take a 10-minute break after you have a chance to get this down. And then we'll probably practice with one worksheet or two, or we'll do one worksheet and then assign the other one for homework and then move kind of depending on how we're pacing, just so we're pacing. But remember, I have recorded videos in the past. So if there's something that I skip and I assign as homework, I probably explained it in the previous class, labeled accordingly. So I'm just trying to gauge the pace. I think some of you it's clicking right away. Some of you are like taking more time to digest it, which is fine. That's normal. That's just how stats works. I'm just trying to be mindful of kind of the pace of mostly everybody. If we need to go through both worksheets, we can do that. I'm thinking maybe one to kind of give you this foundationally, and the other one is very similar, but it builds on some of the rules. Now that doesn't make sense, or there's a big concern, you should raise that. I'm just trying to think of like how we manage our time the rest of the class, and so we can do a little bit of chapter 6. And I have answers that I can reveal to you on the first worksheet, so you can start to check the math to see if it's clicking, making sense, etc. But of course, I want to see you all be successful. So if you have a concern, or you want to give open feedback or sidebar with me about the activity, or you want to dive in deeper to probability, we can certainly do that. Just so try to move it about a chapter and a half a class, just so we don't run into not getting done through all 12 in the next, 5 weeks approximately or so. That's right. There is an ungraded discussion board in there. If you all decide to post your chapter 1 through 4 exam reviews and benefit from each other's notes, that would be okay. Not graded, I'm just saying for the learning community, if that would help you guys. Because maybe the way your colleague interpreted the information might be clearer than how I explained it or how you thought of it. Just a way to try to make it easier on everyone. And if you don't see that discussion board, tell me, I'll make sure you can see it. But there should be an ungraded one in there under in-class assignments. It says exam 1 reviews. I can't grade that. It won't let me. It's got to be where it actually says the exam 1 reviews for the grading queue. But then if you want to see each other's notes, maybe your breakdown helps somebody or vice versa. Does everyone have this so far? Should we say about quarter to 8 or so, about 10 minutes from now or so? Come back. Well, then we'll do a worksheet on probability. we'll do one or two, we'll do at least one worksheet to try to help the math sink in for everybody. So bio break, something to drink, eat, etc. Just take it with you and hide the drinks so they don't say something to me again. So I don't have to enforce the rules. I really like you guys to be able to stay hydrated and such. So. And if you're just totally burned out, when I come back, I'll tell like a funny story or show you a funny video or something to like break it up. Okay. Yeah, quarter two. I mean, take the full 10. I just wanted to turn this like 15 or 14. So if you.
What were you saying about the forms? You were saying something about the form for the test? Or exam?
There should be an exam one ungraded discussion board of every class assignments. And if we all want to, as a learning community, basically go in, like a discussion board and say, hi, click my review, and then put a file there. That will not grade it, that will not be a grading cube. It has to be where it says exam one, and Blackboard says exam one review, where you create the review, where you actually submit it. This used to be all want to give each other's notes, because none of you get the same test. So if the way you took notes helps your colleague or vice versa. And that would also help us in terms of just being a compressed class. If we have time to present stuff, we will. I'm just trying to be mindful of the pace. Some people are like, okay, I got it. But we're like, hey, they got time to adjust, and that's all okay. Trying to think that there's no sense for you guys.
So under student resources.
Should say, there should be an exam one. I might have hidden it. I can look.
I see exam 3.
Let me see. It would be, you might not be able to see it. It should be there though, because I made a copy. Exam 3 reviews. Let's see. So that one's right there. One class activities. Exam 1. Yeah, right here. Exam 1 reviews, discussion board not graded. I'll move it to the top so you can see it easier. Right at the top under in-class activities. Yeah, where it says exam 1 review. Like where it actually asks you to do it, that's like I can put it right below, right next to it if you'd like. That's no problem. Right here. So can you see that now?
Yeah. So it's
Not graded. Blackboard won't even let, like, it's a nightmare to try to, there's no way to really do it. Put it here for a grade, put it here if you want to, to other colleagues, you know.
just any notes.
Well, the exam 1 review, like, you're doing chapters 1 through 4 from like least clear to most clear for you. So you can go in order or out of order, but like, not my notes, like your version of like, how you understood it, or if like there's a concept you struggled with, and you're like, I broke it down this way, and then it started to be clear. This is not required. Like I said, there's no grade. I'm just thinking, way to help you guys, so that way when you're in there, if you're like, man, it's not clicking, you'd have like another resource. Okay, just want to make sure that. So then you just hit create thread, and then. No, it's your review before. So when that was due. Yesterday. It's supposed to be exam, like an exam one, like PowerPoint, Word, however you want to do your notes, covering all 4 chapters.
So you just click on create thread.
Yeah, and then you can attach the file that you probably already submitted, or you were supposed to, because I sent a thing to everyone through Blackboard. The exam 1 reviews, like well as application, in case I forgot to mention it. If you guys need another day or two, like I can work with you, just talk. It's just an exam 1 review. It's just like, here's how I understand.
But I don't see it. That's what my biggest thing is, like signing reports. Oh, it's under 85.
In class, right there, exam 1 review.
Oh, no, I was on it. I was saying that,
I probably should have.
oh, that wasn't there.
Yeah.
Just a sec, you saw that it was like blank. It was like you had to submit. That's why I asked you, you had to submit.
So you submit it there, and then like I said, if you want to share it, put it in the
It's in a
discussion.
hammer. Okay. No, I'm saying.
As any version, like you use your creativity, just.
Oh, right here. This is, okay, so I clicked on this.
Yeah, that's the share.
If you wanna share.
If you want to share.
This
is-
is turned in.
so that I can actually see it, so I have a grade to give you the credit for doing the thing. No problem.
I mean, I've been so long.
Oh. I don't see anything unless we do anything.
I feel like. So why you just. So I don't concentrate. Help understanding. That's what I'm very good. So. You need to rest it out, yeah. So you gotta feel the same. Oh, yeah, and then when we get to this. I mean, but right now, it's not like, yeah, so just, would you guys?
Yeah.
Just-
Very few.
No, not the rate, you.
Was it like the one we had to go like small, split, same thing?
Yes.
I tried it and it wasn't, she's making it very.
Yes, it's like.
No,
So, I mean, they get into. Yeah, that was right, and then you just went, right in.
Yeah, you guys know.
No, 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 but I did put the video.
Yes.
She was like, basically.
Yeah, it's.
She's a sensitive girl. Let her live. I think I'm very used to it.
No, and that's. You know, but he's doing so many. And more and more said that was essentially. Like it was.
Can I say something fun?
Yeah, this clap will work. Why is it?
This is my template. I'm almost done with it. It's for our wedding.
Oh,
Yeah.
that's cool, man. Congratulations.
Everyone spends the best one, so they're the cats.
The cats are there. They're like,
Yeah,
they bear the
they're very
rings.
important. Well, they all have different jobs, as you can see in the ad section. So I had to have ads. I just felt like that was appropriate. That's me as a baby. So she was an assistant, but she's no longer with us. So it's staying though. He's an accountant. She's a seamstress and she's a priestess of a demon church.
Wow.
Yeah.
Yeah, dark really quick.
Yeah. The night is dark and full of terrors. She's a good time. You ever seen Game of Thrones?
Crazy, I don't.
No.
Yeah.
You ever seen Big Bang Theory?
Parts of it. I don't
So
really follow up.
Sheldon's girlfriend is like my friend from high school. And I have to
Is this
find my,
the blonde with the glasses, right?
well, that's just like off the wall. She says the most off the.
Yeah.
She's like, yeah, she's my
I like
alter
her.
ego. I'm like, yeah, she's your alter
I
ego.
love that.
That's the same friend that like took a life-size cardboard cutout of me to the roller skating rink and took pictures, put it on Facebook. Because I couldn't make it from California to visit. And it's not that weird because I've known her since high school, but just a little out there. But if you have at least one friend that's completely out there, makes your life exciting. So.
Pretty much, yeah, it's been.
Oh, that's good.
You know, and then I can.
Yeah. Okay. Well, you have a pretty good team.
I use this.
Oh, yeah. It is. I'm not. So I don't know.
All right. So we're going to in-class activities. Edit, what is today? Today is 7.
Yeah, I see that. The V text, I texted him. On here. Yeah.
I hear, okay. I just have to answer.
Yeah.
Okay, thank you.
So we're going to this homework right here. And then you should have a nice worksheet. That's probability. Yeah, the second page. The first one is review. You may have seen that before. Just work on the second half for now. For probability. This is literally under homework with today's date on it under in-class activities. So just worry about the second sheet. The first sheet is review, which you might have seen that before. That's points. Half of the points are for just the review. So that way you do better on the exam. So you've already seen that. So we're just going to work on the second sheet right here. The probability of selecting. So using this formula, you work on that on your own, and then I'll walk through the answers with you guys, see if your math is making sense. Is everyone able to find that worksheet okay? If you want to talk to someone next to you, that's okay. If you want to work together to understand the math, that's fine. If you feel confused about it, ask me, I'll come around, and I'll certainly see how you guys are doing. Don't just lead your colleagues if you're not sure. That's under in-class activities, and it's got today's date. There's a folder, and there's a downloadable worksheet. I do want you guys to do both pages, but just worry about the second page at this point. Don't worry about page 2. Page 2. Yep, page 2. The first page is like built-in review for the upcoming exam. So you're familiar with that. You've probably seen it before. It's just trying to build the review in.
Oh.
This is what you want to focus on today. Yeah, these 3. I'm chilling. Okay. Arthritis. Yeah, I'm 8. I'm old. I'm near replacement. Both times. Shoulder. Was big. I had 8 years. It was several points of water. It was specifications. 8 ones, yeah. Not sure, maybe some ones never been like that, but they're like pterodactyls and stuff, like they're like, they're all sculptures, like it was the joke. I also did observations. Slowly down.
Sorry.
Yeah, it's not good about it. It's just, they do this so it's great, and then like, take us off, break it, shift. I'm just. What, man? No, it was for chronic, it's still not good. And also, it's just, indeed, there's some patients with my car. Where? So.
I was taught to do that.
I get dressed it, she's a very scary. Is it? My God, there's a Honda. I'm emergency. I I just don't. I just usually. I can't wait to get far.
I'm good.
I trust myself more.
I like to write up with.
Those are friends because it's like. Like you like no.
We really talked about that this morning.
Everything.
Have it as absolutely not.
Literally
The
everything.
probability of us being
Yeah.
friends.
Oh, is it one of
That's
the-
what it is.
Yeah, that's right. But he would never talk to me. And I asked him, actually, if I was never going to talk to you, really, that. Same. I was gonna talk to you. but I didn't want to say. And then everything happened. And he happened to go look at me.
Yeah.
for working.
Oh.
And then we were talking, and then you came over, and we were talking, like, I was like, how they would walk out. He came up, he's just walking behind me. Oh, he's a friend. You're from two, like, chilling.
So then the fusion.
And then we like, you were just in the car. I said, how do you get home for something? I was thinking, that's it. There's no, can't drive you.
You go through around.
Yeah. Yeah, and then you go.
So.
I don't know.
We are with that. And the sound. I meant like abstract.
Is the word. Is the word.
It does.
You're changing what you're pulling.
So you're thinking about, yeah, if you're changing what you're wearing,
Okay.
so you want to think about.
Because the other ones were always on my head, yeah, okay.
Yeah.
So.
So they're given that this is going up.
Everybody is male. So the different research.
Yeah.
So those words too bad.
Yeah.
Oh,
yeah,
Yeah, finish, that'll download, and then just take the download, and open that up and just go to county page 2.
Okay.
And then we're just.
Yes.
Use that formula. But the way stuff's worded, we get like it's like a half one that, well, that's gonna shift like your. Okay. For use.
So it's aspects of
So the problem is that the male participant. So participants, this is everybody. These are all the males, so probability. You have frequency of the thing. No, just divided into the sample size. We're not differentiating, they're all campus on campus. We're just saying, out of all the males, so it's all males, all females, it's good. There's a probability, which you can kind of visually see, but if you do the math, we should 50% or 0.5. Does that make sense? But how it's phrased does matter. It's what, like, about halfway down, it's like, it starts, you know, it's like, given if this or this happens. But I have an answer sheet for this, so like, if you don't have the answer, we can walk through like how to get there. But it's all this formula for this one. The other one, I don't have an answer sheet for. I can still walk you through the math. It's just not an answer sheet. Looks like the first two if you're working. But only if it makes sense. I'll just copy it. Should make sense.
Right.
If it's not, then fine. Just throw it on. We'll go over in a few minutes. I just want to get ready. It has to get all their questions. It's fine. Like, right, we'll do the other version.
This who like.
This on a canvas,
So would be.
given that it's a male, maybe 30 in the female. Does that make sense? Like how we get. You know, so this was off camp, wait. 1 in the 45. So right, off campus. So it's this one, given that he is a male, so it has to be a male. Was off campus out of the 45 sample space by everybody.
Okay.
So it's like. No, hang on. Off campus. No. It'd be in all the off campus. Given that he's the male, feels like that. Because this would be on or off, so if we wouldn't go that way, we have to, yeah, that would make sense. Does that make sense? Am I confusing you? I don't want to confuse you.
So the
45. Look at those off campus. So it has to be, the sample space has to be every this off campus, given that he's a man. That would make sense. Hang on, no, I see what you're saying. Yeah, you're right. Sorry, I had to think about it. It's this into that. Because the given out of all the males, yeah, you got that.
So for
Number 50, yeah. Yeah.
Oh.
I just had to think about it for a second. It's absolutely the same thing I told you. That's what you originally. Maybe thinks of that, right? Yeah. So. I don't think 20 is right. I already figured out where you went wrong. Yeah. 4 6. What is probably is like that? Student goes off campus. So out of all this, so you want to select all the students on campus. Oh, I was figuring out 4 or 5. I read 4. Yeah, so. Which in the frequency of the thing, the sound of space. So what is probability of something? Given this whole campus, so would that be 20? 0.44. Because remember what you want to put in there. Fine. Because would it be? Sense. No. But it's fine.
Give that a look.
It's 20 divided by. You're saying I want to, you know, so all these little campus events, campus actually your sound space. So it's 40. Yeah. It's 20 to 45, not 20. Because if you look at the totals, about
So you're not playing answer them. You're just playing.
In 45 for all the off-campus, because it wouldn't be 20 to 50, because that's all the mail on or off-campus, that's not how that would work. It'd be the 20 to 45. Does that make sense?
That'd be the playing.
Maybe 44%. Did you hear what I said? They're gonna go through that?
I did, but I think it's more the burgers that were, I got, like, even cheese or something, plus on campus, I'm still eating stuff. Well,
20 to 40, because I have to read those off-campus.
that is just.
Good.
Fine, yes. And it's still focusing just.
Off-campus.
Got it.
Yeah.
Okay.
We went to the top.
We go to the answers. We can.
Oh, great. Very good.
Some of them. Which you can look at those, but if you don't know how you got there, it won't help you.
That's
Like, it's just to help you check your work. It's not really just like you copy, because you copy it,
really
and then you use the test, you're gonna be like, what? You're like, what's the first thing about that?
not for the end. Because we first.
That's why it's a test. Oh, they would call practice.
So, friends, and people playing in the 25 to. Or.
It's probably some male student. Or there's all.
So, yeah, because we've been looking.
Would be with.
We did. Look at that.
They're just.
Let's try, yes. So we didn't do that. Just in there, she's probably that's fine, makes sense of us. We scroll up sequences. So one of the goals.
Is that what you're getting?
Yeah.
Should we go over answers or these are the answers, but if any of them are not what you're getting, we can talk through those answers. Or we can talk through them one by one. The idea is that it helps you check your work, not that you just go, oh, cool. These are the answers. It should be this formula, and yes, how it's phrased does matter. And what you want to be thinking about above are like columns and rows, like where is the sample space? What is it out of? And how many people are in that we're trying to divide in for the probability. If you're not asking, I'm assuming that these are all making sense. But like I said, if you want to walk through any of these, I'm more than happy to, or we can go through them one by one. If everyone's like, I'm getting these answers, then I'm feeling like you're understanding probability. The next one gives the next worksheet gives us a chance to do some of the multiplicative and additions.
If you could just go over one of them.
Sure.
Like the number.
Which one's nine's not there? So probability is 60. So what does 9 say? What is the probability of selecting a student who lives on campus, given that he is a male? So you say the probability of selecting a student lives on campus, but we want a male. So 30 divided into all the males, you get 0.6, which is what we have, right? Yeah. So what is the probability of selecting a student who lives on campus? So we want we want to think about this first, like on campus, but we want to make sure that he's a male out of all the males. So now it's going to be frequency of the thing, 30 into 50, which is your 60% or 0.6. Mhm.
And my computer died, you don't have any worksheets or
I-
computer work?
I don't have any paper at all. It's all in Blackboard. I, I can ask him if there's a way to print or something. There should be a way to print in the computer lab. There's a computer lab like two. If you log into Blackboard with your credentials, it's like, I think it's number 10 or 11. It's on this floor that way. You could probably print. I think there's a printer over there, and then you'd have a worksheet. Okay, so we're gonna move that. All right, so I think we have time to do another worksheet. Would another worksheet on probability help everybody? Yeah, okay. You had a question? Just a general one? I don't mind at all. What does 7 say? So that's 0.55. What's probability of selecting a female student given that she lives off campus? So female student given that she lives off campus. What is 7? Yeah, so you take a female student, so you want to select a female student, so you think that this row first, but out of everybody that lives off campus. So 20 into 45, which would be 0.55.
Should be 25/45.
Yeah,
Oh, thank you.
yep, no problem. All right, so I'm gonna move this so you guys can actually see this. Hang on. Student resources, in-class activities. Where's it? There we go. Make available. And then we're gonna move this up. So I just why? Oh, that's why. Let's change it so that it makes sense across the board. 7. 7.5 part B. Move this all the way up to the top so you guys can see it. Okay. So let's go right here. And then student resources, in-class activities, today's date, part B, and then you should get a downloadable worksheet, and then enable editing. And then there's a new chart, and then I asked you, yeah, let's do part 1 and part 2, to come up with some of these and then some of your own. So maybe do your, so we're gonna use this. So probably this is the male participant, for example. These are all the males. So we 192 and 387 for the first one. I do not have an answer sheet. I can walk you through these, but I don't have an answer sheet for these. And then I'm encouraging you on the second half. We're not going to worry about part 3 yet. That's part of chapter 6. Come up with like 13 of your own scenarios, like using some of the additive or multiplicative rules. And there's some of that in here as built in. Then you get a chance to create your own.
You say there's a third one too?
There's a part 3 we're not going to worry about.
Well, you're not worried about it.
We're going to do part 3 eventually.
Okay.
And I'll maybe make the demo make more sense, like have this maybe 2 weeks or something, so that you only have to submit it once. And we'll probably be doing that one next class period with part 3. So my plan is to get you guys through this a little bit, and then take some of our remaining class time and talk about chapter 6, but not all of it. And then it'll be able to pre-test and post-test all the way to probably 7. The pre-test, the post-test up to 6, and then we'll cover the remainder of 6 all 7 next time. If you're talking to me, I'm not unreasonable, you can't really. I just need those. You need to see that? You mean the answer, Ollie? Ellie? Right here. 50. Not the new one, on the old one. The worksheet we just did. The worksheet we just did, the answer is. I don't have an answer sheet for this one. I can walk you through the math. Or tell you what you would do to make it make sense. But I don't have an answer sheet. No, submit them in their own folders.
It's in the same spot.
So each one of those has point value. Oh, so yeah, that one, yeah, together. So like the first half of that one, the scenarios from chapter 1, and then the stuff we just did.
Yeah, that's all. Then answer.
You can do that, yeah, that's fine, as long as, yeah. It's, I'm trying to build the review in, if you know.
Yeah.
The first half is from chapter 1. You may already.
So I just put the folks name with it down.
Yeah, that's fine, I can take that, yeah, that's fine, but you wanna make sure that's in there too.
So the answer we don't use for just keep it for.
You said I would take 0.5 if you wanted to round out, that would be okay.
Okay.
Yeah, if we need 2 decimals, that's fine.
Just wanna make sure.
No. I would probably hit 0.496 or 0.50 for that one. But we'll just do 0.50, let's just do hundreds, that's easier than us. This is a general rule, I think your pre-test and your post-test are the same thing. Yeah.
Cause I feel like most of them, like whenever I was doing some of the equations. Get it together and then conventional, I like the multiple times.
I'm doing that on purpose, I'm trying to give you guys a really good shot at doing all the classes. So 50-50, so if you sat here and you caught there, you would understand it, you would probably do not so great at it, because not your points for exams. But two attempts on an exam, you have nerves.
Cause I know like with the pre and the post and all that stuff, like the answers that's gathered is the same thing, just like.
Oh, no, it's way more, I'll worry about it, it's like a test bank. And test 1 for exam 1 is not test 2 for exam 1, they're different, it's the same set, but it's not the same questions.
So it's the same thing as the post where they're all scrambled around.
Yeah, but it's a much bigger test bank. Like it's really, because it's an assessment, like it's an exam, like it's not, like, they're doing that with pre-test and post-test, those are like miniature or a baby version of it, there's less of that in the pre-test, post-test, you get all the tests. And you totally don't points over time, you just got to walk me through it. The exam, you're gonna have to know, because
It's a whole different question.
it's a whole different question, it's not gonna ask you the same question if you, on the second, it's gonna ask you the same content, like probability or whatever, well. Not
Not the
probability,
same equation, like,
same content.
so like question 1, question 2. It's kind of easy.
It's more complicated, but yeah,
Looking forward to it.
that's an assessment. It's so that's just practice.
So let's ask it, what is the probability of something team is to give a chance? Is the top of these students, or are you looking at different form of program?
I think that would actually be aware, wouldn't it be, put you with one bait? Yeah,
Okay, so.
yeah, but that makes sense, because she has to be in public to select her.
Yeah.
That makes sense when it sounds split up.
Okay.
Yes, I don't understand, just trying to.
He was confused.
That's what I did.
More so.
Oh, Lincoln. Oh, Lincoln. Oh, that's right. Okay.
Yes, so then we're doing, this, the student get, because that's a now. So it'll be. No sort of names that's can. So. Got it.
Yeah, does that make sense? So it has to do with like columns and rows, like how you're compiling questions. It's like quick with the like, again, sure.
Yeah. I like what got it, but I'm just trying to, I guess it's up to say, I need to use better way. I think it's just for people to ask.
Question. I like percentages, and so since this is all just percentages, it just makes sense to me. And we'll look at it. So,
Or you're not, I'm just specific.
No, he is. He is.
yeah, like maybe a little bit.
Okay.
Probably, maybe not.
It looks right.
This is the next year.
You have those?
Like my shoes is that. Shoes are super sweet, so very. You guys should probably look at that. Yeah. So it's the more, I figured.
We are.
She's not. Yeah.
Yeah.
Pretty great answer that.
Oh, so I put a folder in there. So right there,
Oh, perfect.
be heartbeat. And there's don't worry about part 3 yet. I'll probably do it like. No, next week or something. That's what we're doing right now. It's that, and that's where scenarios, and then probably.
Oh, you're two different. I'm good on the same page.
Yeah.
That's probably.
And probably like 10 or so will probably go into the last one. After 6, 6, so. But when you get time to work on it, you also have to hand it all in tonight, and we're asking questions, so like, what is this asking? It doesn't make sense. But there's not really an answer for this, I will be checking your work when you guys submit it, but I don't know when yet. So you can sheet, you're like, here's all the answers. But if you're like, what is it, you know, walk you through, I get the answer, and just. So it's.
So then can I ask about like how?
Yes.
Okay.
Yeah, sure. Because if you do that and you're off, I can,
You know where my ear.
I know where your error is.
Okay.
But like this is given, you're thinking probably like horizontal. A lot of these. Cause I was just expecting that, it was given that for some.
Yeah. Don't start.
No, I mean, like I was trying to give you a tip, so. it would be easy.
I just wanna make sure I got it.
Yes, sir.
Divided 1, 2, 5, 3, 8, 7, 4, 9, 6. So we're about 1.5.
Yeah. Let's do hundreds, yeah, just one nation. That's for hundreds.
Oh.
So if we can get to that, we're good. Guess we can get to the Z. Okay.
We've got a lot of work together, and one question, we can ask questions. But probably 30 will start at 6, just so we know. Cause we'll probably get some slides, just make sure we're on 16. So I think it's 8 weeks on the already called chapter, I can't do 1 chapter a week. We'll run out of time. Or I have to say, tell you guys to watch my recording, I'm trying to get you the one. So I'm like, work on this a little bit, ask questions. And I will be doing until we back to meeting with this. Because of that third part.
Criteria, it's needed, maybe 13 questions.
Because of the table.
So based on the table.
Because of the table, what would this be? And then you go to that. If you don't want to, because there's 2 questions, the other that will be okay. So that, and that's in theory to world.
A lot.
So if you want with your questions, you might use the worksheets from.
Okay, well, actually, I'm just saying.
But we're not doing 11 or 10 or 9.
I'm gonna change it on the sheet.
Well, I think before I'll give you what we need. I know that I'm gonna. But I don't think 5 or 7, I think we should try to follow the rules.
We can start combining them too.
Does it make sense?
I get it. This one's.
And then the idea is like, you guys might be able to just consider your own ideas.
Like, just make her do this.
No, use my table, there's some other scenarios, there's a lot,
That makes.
there's a lot of scenarios. No, you guys don't do extra work.
All right, I did.
But the idea is to apply to like conditional, the mutual outcomes, there's the additive, the multiple, I don't know, you said do it. So you type it, and it's here, I got this. So this realistic can probably do like. Probably half next class year, because I'll chapter 6 a little bit, and try to get so half actually like you said, the next week, I'll be second half 6 come off, so that's presidency next week, chapter I can't do.
Yes.
Well, I'd love to do that for you guys, but I can't. So, but if you have questions or it's not making sense, either ask, please, so increase recordings and or the tutoring, but that's probably your first thing, so if it's all the job on, just talk to me that, or ask them, like, it's just changing, it makes sense to you, that's. Or we Zoom session, like. Outside of class, like, whatever I can try to be, just on one person. But however, so we alternate one. They're supposed to work. SBS on all computers, these are live computers. Last thing, most recently was last week, they were supposed to 100% work. If you have internet, you should log it on. Make sure you turn it on. Down here. Yeah, he says, yeah.
Like you said, going on, where you make that, it's the one.
You know, who's in there, you're gonna log into on the phone right hand side. Oh.
Yes, so I, yeah.
Do we run the catacombs quite little?
I think,
These don't look bad. Is that right there? There's no you should do. If it's, wait, is that mine? Is that mine?
Yeah, this is.
Then you might be right.
The new ones.
The new one you might be right. Because I have an answer sheet, I have to do this by hand.
Okay.
So if it's given, it's usually horizontal. If given is in there, usually going horizontally.
Yeah, that's the same one.
And they could be that well. I don't have an answer sheet.
Yeah.
Yeah, that makes sense.
That's good, right?
Yeah.
You know. How's everybody doing? Should we start chapter 6 or you want 2 more minutes? Should we say 8:30?
Yeah.
So what you, so. propose to make it? For one?
Yeah, right.
I mean, obviously will be. All the first one and 2 hours for each, so. Yeah. Number 1. Yeah, so I'll probably send you the offers. Yeah, those make sense, so, that's what you can do, right? I mean, I understand the letters, so. Yeah, that is a little like half for that and stuff. And they combine them, that does actually work. Yeah. Well, I was doing a workshop a couple of years ago. I started doing that as like a. Or as master of work, so it's not like, it's not formally, you write, but it works. And if you understand how to get there, you know, if you like other. So I'm pretty sure that the rules out is for work. Yeah. He's probably right. And that becomes the deal, because that just sounded right in my head. That's the thing you're looking at. I think you. No, I didn't know. I didn't know if I know for other jobs. The only other guy that works here is part-time, and everybody else has 30 years of place for one. That's the only guy, literally, you're gonna find.
There's a lot of those like, yeah, so many. Student politics and what? And you're thinking about.
Yeah, well. And I just speak to the word, and I said,
I thought of that is. So, makes you. Your own scenarios are based on my table, you can have to create a new table. It's just my table. Figure out, because that came up, some of the people just started listening. Yeah. We could, but I'm trying to also talk about civics.
Yeah.
Oh, you know, we could do, maybe bring your answers for next class. Or maybe I could like post some answers for the first, you can post answers for you guys. I probably won't have it tonight, but I can do it for next class, like the first 2 days. I can just do the math, post the answers for you guys, and tell you how I got them. Just, it's just because it's just even Thursday, so we have to do a lot of check work. But yeah, that's in. I started at 8 today, and I live in Park, so I'm probably not doing it tonight, I'm probably going home like, miles of Tassie. So, but yeah, we got just like post answer sheet for this, sure. Not, obviously, I sure all mine. Okay. So what I was thinking, everybody, is start at 6, but I can create an answer sheet for the first 13 and post it in the next couple of days for you guys, the next day or 2. Probably not tonight, realistically, because I live like 30 minutes away and it's late. But in the next day or 2, next couple days at the outside, but I can make sure it's there before next class so you could check your answers. You're not gonna have an answer sheet on the ones you create, obviously. That's just gonna be how you create them. But you could ask questions if you wanted to check with me or check those. That would be fine. That way you don't feel like you're lost or doing the math wrong on these. Everybody ready for 6? Any final questions or concerns on probability? I'm not going to make this worksheet, the second one, due until like after next class because the third part we have to do. So that way you're not submitting it over. So you still have time to work on this and I still have time to give you guys like an answer sheet on those. So if it's making sense, great. If you're still like kicking it around, you're okay. All right. We're going to talk about probability, normal distributions, and z-scores. Talk about characteristics of it, what a statistical norm is, standard normal distribution. We're going to look at the unit normal table, which is literally posted in chapter 6, and we're going to refer to it pretty much a whole bunch the rest of the course. Locating proportions, locating scores, going from binomial distribution, and we're going to try to get through about the first half of this lecture, approximately today. So normal distribution, that is basically the bell curve. That's what that means when you see the word normal distribution. It has to do with how the scores fall, making it a normal distribution. This is a normal distribution. It has to do with the clumping, basically, of data, which we'll get into. A normal distribution a lot of times used with like intelligence scores. Everybody in this room is probably here or higher. Okay, like this is the average. Every 15 points, when you talk about a standard deviation with intelligence scores, represents a jump in what you can or cannot do cognitively if we use the standard Binet. Stanford Binet. So 85, 70. You gotta be like right here just to like go to like K through 12, by the way. If you're below this, you're not going to K through 12 in terms of traditional intelligence models. Every 15 points, when you start to get like over here, you start to approach what we might call genius. This is just one way to measure intelligence. If you have it for Gen Psych, you know, there's a lot of different ways we can think about intelligence. This is the most traditional model. That's the average, that's the bell curve. You can also use this if you go to like Celery.com, PayScale, Glassdoor, ask for the average for pay. That's not unreasonable. I will be cage waiting for that in about 15 days with my boss. Good times. 3% raise, inflation was 2.9. Really? We're doing that, guys? That's why you want union, because we're asking for 5 here. So symmetrically distributed by the mean, median, and mode, which means your mean, median, and mode are all going to be right here on top of each other. You probably saw that in the lecture that you watched. Scores closer to the mean are more probable than scores further from the mean. These scores right here are more probable than scores over here, Generally, we assume a normal distribution when we gather data. You guys this so far? Yes, no? Okay. These are examples of what normal distribution looks like just what I drew there. Standard bell curve is your normal distribution. All right. right? Ooh. So a normal distribution mathematically defined, the shape of a normal distribution specified by an equation relating along each score along the x-axis, with each frequency along the y-axis. It's a formula. The one we're going to use is way simpler. It's just more for your own notes. Remember, rarely do behavioral data fall exactly within the limits of the above formula. This is why we're not going to really be using, at least in the assignments I'm going to give you. Normal distribution is theoretical. Behavioral data typically approximates normal distribution. Do we have this so far? Yes, no, okay. Right, the mean, median, mode located at the 50th percentile. Normal, that's what I literally drew right there. The mean, median, mode, half the data, 50% fall above, half fall below. That's our halfway point. mean, average, median, like moving towards the center at the same pace, like the midpoint, median. Mode, the number of times you see the thing happening, like with your data. So like, which is probably review from you guys watched, but like, if I write my phone number, should all have in case you need more urgently than email. Our mode are the fours because there's three of them. So mean, median, mode. Mean, average, median, like right in the center, gets rid of outlier data because outliers can pull on it, like salary averages, for example. And then the mode's like the thing that happens the most in the data. So the number distribution is symmetrical. Again, that's a bell curve. If you fold the paper in half, you have a perfect overlap if you did that exercise. So mean can equal any value. Mean can equal any number from positive infinity to negative infinity. And that's just showing that right there, right in the center. Standard deviation can also equal any positive value. Data can vary from standard deviation is greater than 0 or not vary, that it is 0. Describing variability, how much scores vary, as negative would be meaningless. If you remember from the other lecture, scores only when they vary, that's when you have the variability. How much they vary from each other. So if you have one score that's different, you have variability. Not variance, variability, how much the scores vary. Also known as variance, standard deviation. Pretty much the same thing. So total area under the curve is equal to 1. Area under the curve, we're looking at this now. Can never be negative. It's between 0 and 1. I'm gonna start to calculate that. Portions of the area used to determine probabilities for normally portions of the area used to determine probabilities for normally distributed data. Again, normal distribution, regular bell curve. Tails of normal distribution are asymptotic. They're always approaching the x-axis, they never touch. This allows for a possibility of outliers. So what that means is you have your X and Y axis. It'll never actually touch the axis asymptotic. It's better drawn like we just think about just the x-axis and then they never actually touch it. It's the idea. Which allows for the possibility of the outliers, the random super high and super low pieces of data in terms of what outliers are. Does everyone have this before we move on to the next slide? Okay. So this is the proportion of the mean. This has to do with how the scores fall in terms of the number of standard deviations. In terms of 1 standard deviation, how much data is there, 2 standard deviations, and so on, and the percentages. And because of how the data falls, this shapes the bell curve. If the data didn't fall like this, we have a skewed curve. Does that make sense? Everyone, I'll leave that up there for a moment. This is the same thing I was just talking about, standard deviation of the mean that shapes the data, the percentages. So researchers use the word, will use the word normal to describe behavior. For example, we might look at researchers studying links between obesity and sleep. Short sleepers that are higher risk of obesity compared to normal sleepers. What does it mean when researchers say normal sleepers? So this would be operationalizing a variable, and understanding what the word normal means to describe sleepers. So we have this before we went to the next slide? Okay. So only about 5% of data of the tails falls beyond 2 standard deviations from the mean. These data are not normal or likely. 95% of the data will fall in about 2 standard deviations of the mean. These data are normal or likely. And again, that shapes the bell curve. So that's just the same thing. So standard normal distribution, mean is equal to 0. Standard deviation equal to 1. X-axis is distributed in z-score units. The z-score is the value on the x-axis, and standard deviation is the number specifies distance from the mean. How many standard deviations? So like the clumping of data. Like intelligence scores, what you can do cognitively or not do cognitively. this one and then one more slide, and that's exactly where we should be. So it'll kind of probably hit us right on time. It's just the formula, which is exactly after the lecture. So I'm gonna try to knock out this and the other one, and that would be it. It would be pre-tests and post-tests through chapter 7 pre-test, post-tests through chapter 6, and the one worksheet we did tonight, and the exam by Wednesday. That would be it. The other thing we did, the second worksheet, I'll post an answer sheet for those first 13 to give your own 13. The third part of that, I can't assign that yet because that's tied to this. So that would be due probably like after our next class period. The second worksheet we did. Like I would probably have those by next class period, but you don't have to worry about that third part or handing it in yet, if that makes sense. So you're not doing multiple submissions. And then I will work on getting the answers pushed out to you guys for those second 13 or the second 12 that I gave you. So you're on the same page. Or if we're, well, or we can just stop here because I feel like, I don't know if I'm gonna be able, you guys are able to take notes in the next 1 minute on the next slides. Should be reasonable. We're 15 slides in, we got 33 slides, so we'll do the second half and 7. Is everyone feeling clear on the homework and the quiz, like the test? So pre-test and post-test. The exam has unlimited time. I will take the higher of the two scores. Your pre-test and post-test, you can take an unlimited amount of times until the due date. If you have a concern or you're falling behind or you're concerned, talk to me or sidebar with me. I can't really stay down here, but I can certainly talk to you guys outside a little bit before I jump in my car. If you have something that's like freaking you out about the class or you have a big concern, I will talk to you, okay? Have a good one.
You too.
See you next week. You're welcome.